one of the first things I want to touch on now is a key role that sulfur may possibly play in the future. One of the suggestions out there, in fact, if climate change turns out to be at the upper end of what we expect and we don't get emissions under control, one could use this offsetting property of sulfur compounds, sulfates, and inject aerosols into the stratosphere as volcanoes do, which act to cool the climate, and do it at such an amount that we offset the warming. It's sometimes often called a type of geoengineering. So I'd like to ask Henning to, I think you have a couple of slides you might want to show us, and just tell us a bit about geoengineering using sulfur compounds and your views on that.
Well, I had planned to finish off my talk with this observation here, like, if everything else fails, I'm speaking this one, if everything else fails, how about doing what Pinatubo has done and other big volcanoes have done? This record is global mean temperature. The blue line is global mean temperature as a function going from 1985 up to, and you see the Pinatubo eruption occurred in 91, and then immediately after that, and the following half year to 1 year, the temperature of the Earth dropped by ½ degree or so. And the sulfur, the reason is that the sulfur from the Pinatubo went up to the stratosphere, spread out over a large part of the globe, and acted as a shield for preventing some of the sunlight to penetrate down to the surface. So in principle, if one repeated this natural experiment artificially, one could get something like what Paul Crutzen, our friend and colleague here, suggested a few years ago. You can enhance the albedo of the planet by stratospheric sulfur injection, a contribution to resolve the dilemma. He said that he didn't recommend that we should do it, and I definitely do not recommend that we should do it, but it's out there in the literature, and I think it should be mentioned because it's something that can be studied and is being studied. The thing is that it doesn't take a lot of sulfur to do this, and it doesn't cost all that much money to do it. So it's technically feasible, it's economically feasible, but I think it's for other reasons, moral reasons, ethical reasons, not advisable to do it. But it's out there, and it's been suggested it can be done. I hope nobody ever will do it.
Okay, thanks, Henning. Just before I ask my panelists to comment on that, I want to tell you a little story, because I was working closely with Paul Crutzen on another topic. That's this idea of the Anthropocene, which Henning actually mentioned in his talk. But at that time, Paul was doing his very first calculations on what's now called solar radiation management by injecting sulfur into the stratosphere. So he wanted to do a first-order calculation of how much sulfur would it take, and could we afford to do it. So he did that calculation. This was some time ago, and in terms of getting it up there, his idea was, well, this wasn't long after the collapse of the Soviet Union. They had a lot of big rockets they were trying to sell or lease out or whatever at very low price. So he said, how many rockets would I need to get this sulfur up there? And of course, you have to keep sending it up there because there's a residence time that you've got to keep repeating it. And so he came back absolutely white-faced into my office. It was up in the academy here, saying, Will, do you realize that one human being could throw the Earth into an ice age? I said, what do you mean, Paul? He said, I calculated how much sulfur it would actually take not only to counteract the warming, but to drop the temperature another 5 degrees, which is about what it would take for an ice age. And he worked out that Bill Gates had more than enough money to do that. So that gives you an idea of how feasible it actually might be. But panelists, would you like to make some comments about this idea of geoengineering using sulfur? Yes,
yes,
there you go.
I think it's very interesting to bring this issue up. And well, as far as I know, this is a completely unregulated area, and which means that anyone can do this. Of course, even if it was regulated, anyone can do it. But I think this is something that the International Law Commission has started to think about. I think they have started to think about the law of the atmosphere, bringing up issues that are not automatically covered by any conventions. And I think this is an interesting question. I've been contacted by a Japanese lawyer a couple of times on this, particularly on the regional air pollution. But the question is, well, all our conventions and other regulations, they are human-centric. But here we are looking at a convention or a regulation that are atmospheric-centric. And I just want to raise a question. While going from a human-centric approach to a more atmospheric-centric, we have ecosystem-centric approaches, as you know, but what is the feeling of thinking about this?
Deliang.
Yeah, I think it's also quite interesting to look at the development and both in the scientific community and also in the society. As I remember that in 2009 when we started in the International Committee to discuss the future grand challenges of the global sustainability. And the US National Academy was doing the similar exercises. It was very interesting. They came up with actually 4 grand challenges, which are exactly the same as the International Scientific Committee came up with. You can imagine prediction, data, etc. And there was one that is missing in the US discussion. That is we call it innovation. And part of that innovation is actually geoengineering. So I remember that when that was first put forward, and we also see a lot of criticisms, which was the case before, but we also see a change of the attitude. Personally, I believe that there is something to gain to not to immediately to do it, but actually to do the calculation that like Paul has done. And indeed, there is, because of this Earth system linkages, as you said, that we should not only focus on atmosphere, we should not only focus on one specific region, etc. So it's the whole system we have to take care. And we do have the Earth system models today. And I think there is a lot to be learned by playing with this type of models. And indeed, they are designed to do experiments with type of things that we're talking about here. So I'm happy to see that the international community has already started to do many standardized calculations with geoengineering ideas. I think that is exciting. It's not maybe in the end we will not to do it, but I think it's a good exercise. We can learn so much. In fact, also in practice, we're already doing some of these experiments. And you probably all have learned that during the Summer Olympics in Beijing, there was another limitation of the emissions. That has an impact. It was a pretty long period of time. I was in Beijing during that period of time. And also this year, I was in Beijing again in September to a national celebration events and also celebration for the Second World War. It was the same. It was some measures taken weeks before that event. It was blue, beautiful. You never seen this kind of sky in Beijing. So I would hope that they have connected data before and after. And also during that period of time, I think we should be able to learn quite a lot different processes. So that kind of experiment.
Carolina.
I think just in this case concerning the particles injected into the stratosphere, it's feasible, you say, but we are dealing with 2 components that are acting on very, very, very different timescales. The particles are very short-lived, even in the stratosphere, compared to the accumulation of carbon dioxide in the atmosphere. So even if it's feasible, there is a large risk, and you have to undertake a large responsibility to keep injecting for thousands or more of what do you say, in over thousands years to come, because that is the time scale where we still have to deal with carbon dioxide that we have presently in the atmosphere.
And of course, that brings up the problem is if you have a breakdown in governance at any stage in that time and you interrupt the injection of sulfur, then you have a big stock of carbon dioxide in the atmosphere, which could lead to some fairly abrupt warming.
So that is the danger.
Yeah. Mary, did you want to add anything?
I was just thinking of analogies, you know, and I understand the issue about what they're referring to now as space law and what's that including. But I was just thinking of the test cases that they had in the oceans on iron fertilization. And people spoke about that for a long time and said it was right or wrong and ethically not responsible, etc. But as soon as somebody did it, and it was challenged, and it went to the Human Rights Court in Belgium, and they stopped it immediately, and they said nobody has a right to, I think the way they put it, to pollute or to perturb something that was not ours. It was a very strange ruling, or the wording of the ruling was interesting. And I wondered if you did that in the atmosphere, and you also took that to the Hague, would you have the same kind of ruling? But we did a modeling experiment just for fun of what would happen, well, we thought it was fun, what would happen if you had multiple nuclear explosions. And it was in a science article, and I just happened to chair the Science Advisory Board of the Max Planck Institute in Mainz, and they did the modeling exercise. And I got phoned by more journalists in 1 week as a result of that article, that in the end we decided it was really a stupid thing to do, because we'd raised the fear level of people so high that they didn't even want to consider it. And it was the people of Europe mostly, the citizens, who did not want to even think of what the negative impact would be. So, yeah, whilst we may be cooling the planet, I'm not sure how the citizen science would respond.
Henning, do you want to comment on that?
I had one comment to what De Liang said. It sounded as if you were quite positive to the idea of making what you call experiments with models, etc. One could learn something from that, but I'm more worried about the other side of that coin. That is, you might influence or make the politicians believe that this can actually be done and should be done. If you talk too much about it, so even when Paul Crutzen published this paper, there was a lot of criticism from his colleagues and from some of us that you have to open the bottle of Aladdin, or what it's called?
Pandora's
box, yeah. Now it is open, so that's, I mean, we have to accept that, but it's also true that in some circles among policymakers in big countries towards the West are thinking in those terms. That maybe we need not do anything now, we can wait and see if it gets really bad, we just go ahead with it, which I think is dangerous.
Yeah, I'd like to ask you a scientific question about this that I've always wondered about and never got an answer. The lifetime of these particles is short, even in the stratosphere, and they're obviously going to come down to the surface of the Earth. And you talked earlier, I think the first point of your talk was about acidification of the surface of the Earth. How big a problem is this going to be if we're going to continually rain down sulfate particles from the stratosphere?
Yeah, I mean, it's pretty small quantities. Each time you emit them as pretty small quantity. But of course, eventually, if you keep going like that, you might deplete the absorbing capacity of the soils. Right. Eventually, you will do that. I mean, we're talking here, but in this experiment, Paul's idea was sort of a few teragrams,
right?
Which is just maybe a 10% or even less than the present human anthropogenic emissions. But you are right, if you keep going.
What might that do to the ocean, Carolina? I mean, the ocean's 70% of the surface, so a lot of this is going to find its way into the ocean.
Yeah, but if you deposit sulfate, there is lots of sulfates in the ocean, so that's not...
This is a small...
Yeah, that's not...
Any issues? Yes, Sibyl.
I'd like to comment on this because I just think that...
We've got a microphone coming, so maybe we can hear.
Thank you. I'm Sibyl van den Hoof. This is very interesting because this is really another end-of-pipe type of solution, and it completely ignores all the other aspects that are related to the climate issue, which is the fossil fuel addiction and all the wars and conflicts that go with the fossil fuel, all the negative impacts of burning the fossil fuels that some of you talked about. So it's, to me as a citizen, it's a completely absurd solution because it comes again doing more of the same. So I must say it's really always, every time I hear about those kind of big geoengineering solution, I think, are we that stupid?
Yes, we have another comment back here.
I can't help to be reminded of all the debates around nuclear winter in the 70s. And some of the people who wrote the key papers on these were the same people who ended up in the IPCC. I mean, we seem to have come full circle. There was value in actually doing the calculations about nuclear winter. It was a fear factor. And that did have influence on denuclearization at some point. So I think there is value in looking at the potential impact, whatever that impact might be, as long as you don't send the message, oh, just go ahead and do it.
Any other comments out there? Yes, Pei-Jung, you want
So very good that the seminars let me know more stories on sulfur and climate change, health, and others. The comment is, for the generally audience or for generally the governments, we would like to give a very simple understanding of the stories. CO2 linked to temperatures. SO2 linked to precipitations is right.
So your question is the link between change in SO2 in the atmosphere and precipitation changes. Yes. And I think you're reflecting one of the common concerns about geoengineering is it's going to change rainfall patterns and lead to conflict over that and so on. People who know sulfur more than I do, is that a real concern, Henning?
Absolutely, I think so. I mean, if you start changing the energy balance on a global scale like that, you're bound to change not only the average temperature, but the regional temperature, the regional hydrological cycle, and the rainfall. And so it's going to be very hard to predict exactly how much and where, but it's bound to happen.
Yeah. Maybe we should just conclude that, you know.
Is it time for scientists to conclude?
Yeah, I think we
all
should
right, we've opened up
conclude.
Pandora's box, we've examined it carefully, it's time to close it? Maybe we
I
should.
think we just can conclude that we need to cut the emissions of carbon dioxide. So.
Yeah, there was another comment, yes, up the back, please.
I want to ask something. From the time that there are other ways to reduce to take from the atmosphere the carbon dioxide, why do we concentrate on sulfur, something that is quite dangerous? So why the scientific community gives attention to something so dangerous, while policymakers and lawyers and politicians, it's evident that do not understand very well the science? So that's my question.
There are two ways, you know, in geoengineering, there are two aspects. Either you hinder incoming solar radiation to reach surface and to warm the surface, or you just take care of the carbon storage. And those are, you know, a number of suggestions to do all this. I don't know, you know, it's more a question of moral or philosophy here, if you want to take them on or not.
Why the scientific community concentrates on something so dangerous?
I'll get, yeah. I'll give you my take, and my colleagues may violently disagree with it, but I think the problem is there's still a lot of thinking in the scientific community about cause-effect in a fairly simple way. So if we have a problem of too high temperature, we know from the volcanic eruptions that Henning showed that we can that cools the Earth, and what it does it by putting sulfur in the stratosphere. So it's simply taking a part of the system in a very simple way and saying, well, maybe that's how we solve it. But a lot of the concern that's been raised around here, and this follows on particularly from the talk of Carolina, is that we really are talking about a very complex system in which biology plays a very strong role. And when you hit it with a big hammer, there are many other effects than the direct one that you talked about. That's where I think Earth system science does have a lot to say. Henning mentioned it's going to affect regional temperatures, it's going to affect precipitation patterns, all these sort of things. So I think in response, the reason it comes up is I think science has had a long history of taking pieces out of a system and studying them in a cause-effect way, and that's pretty much the thinking that's behind there. Whereas in fact, I think most of us on the panel are sort of beyond that and are thinking about the Earth as a system and all the other things that can happen if you take a simplistic approach. So I think that's the difference in philosophy, and that's why some in science would raise that as a possibility.
I think we probably need to speak in a very clear way that we do think it is interesting, but we don't believe this is something that should be done, and we don't even focus on it, as you probably understood. We don't focus on the sulfur as a solution. Henning has a conclusion that in the long term that is the carbon dioxide that is key.
Yeah, that's right. Any more on this topic? Because before we close, I want to raise one more. And that is, we're talking, in geoengineering of introducing additional sulfur into the Earth system. My question is, having worked a lot on the planetary boundaries framework, where we're thinking about restricting perturbation, change to big chemical cycles, and we already have carbon, phosphorus, and nitrogen in the planetary boundary framework with proposed global boundaries. Do we need one for sulfur? And if so, why? Is it just a regional problem, or should we consider it now a global problem? Henning showed how much more than the natural amount of sulfur circulating through we're now introducing through human activities. What do you think? Do we need a planetary boundary on sulfur?
I'm not sure we need one. I mean, in the coming decades, we will see sulfur emissions decline. And so I think in 20, 30, 40 years, there'll be much less sulfur, anthropogenic sulfur around. And the problem, that part of the problem will not, if not completely disappear, at least become very small compared to other problems like the carbon cycle.
Your trend was quite clear that it's going down. Yeah. Per Inge?
Well, it's a very simple answer on this will be, it will disappear with a carbon policy.
But still there are health effects to be concerned with.
I think for me what's an issue is where sulfur has been studied intensively in the world is where the soils are much better buffered. So if you look at the younger soils of Europe and the younger soils of the United States, they can essentially tolerate much more sulfur as particulate deposition than the acid soils of the tropics. And I think perhaps, sometimes I worry and then sometimes I don't worry, because we can quite easily solve acidity of soils if you just add lime fertilizer. And that's what people are doing all over the world in acid tropical soils anyway. So instead of putting on 8 tons of lime, you just put on 8.5 tons of lime, and then you do away with the acidity problems of sulfur. So what does keep me awake is it seems as if the sulfur additions are insidious. They just keep increasing and increasing and increasing. And in the southern African systems where the soils are these very acid soils, from these power stations, we've got data now for over 25 years, where we cannot show that deposition from the power stations have actually overall significantly decreased the pH of the soil. Essentially, the pH of the soil is so acidic anyway, just putting on an extra little bit of sulfur is not a problem. And then I say, no, it is, because my whole research program's about this, and we've got to fix it. So I think in the big picture, I would go with Henning, that the sulfur issue is probably going to go away in the next 50 years.
Is that true for China, Daliang?
Yeah, I'm also very convinced that, not least because this of the win-win situation in the policy context, that climate, when you cut down the emission, not only good for the climate, but also good for health, air quality. The Chinese president made a very strong statement recently, which I was impressed. And he said that it is because, as you know, that like in the US, there are also some people in China who are skeptical to climate change and also even think there can be some conspiracy from the Western side. But he said that stop talking about this. It is not that we are asked to cut our emission. It is we ourselves have to do it for ourselves. I think that is really a clear statement. And also, I think we can hope with that. We can hope there will be a very strong commitment too.
But I'm not so convinced of the commitment. And I think in the developing countries, there is still a large risk for using coal, oil, and very sulfur-containing emission sources. So I would be leaning more towards some regulation until we see it's working.
Beringer?
Well, yes, but if you go through the interest in controlling air pollution versus, or sulfur, including sulfur, versus climate change over the globe, you will see in the developing countries that they are putting larger emphasis on air pollution than on climate change, for sure. And you can also even see that in a country like the United States, that air pollution is, well, at least at the same level on the agenda as climate change. And that means, of course, that we have an opportunity here to use the win-win approaches here and not going for end-of-pipe technologies when we are talking about cleaning, air pollution measures, but rather looking for the more long-term solutions that include the carbon dioxide. And so I think this is something that we really need to think about. And since we are taking first the costs of flue gas desulfurizations and all these things, and then 5 or 10 years later should close these facilities down, then of course we are paying it twice, we're paying measures twice. I think that is something that we should avoid.
Henning?
Now, both you and Bill Young talked about the win-win situation all the time, but I think still with sulfate we have a win-lose situation. To take away the sulfur, which I think we have to do because of the health, but you will lose some from the point of climate. Yes, we have to accept that, but it's not a clean win-win situation. It's kind of a win, slightly lose.
Well,
situation.
I disagree, I think, since if you go for a reduced carbon dioxide and sulfur, at the same time, will you really lose climate effect?
Yeah,
Well,
We have to calculate that.
But I think your point is there's already carbon dioxide up there now that's being offset by the sulfur. So if you take that off, even while reducing CO2, you have somewhat of a win-lose, at least for a period of time.
Yeah.
If I understand that correctly. Any other comments from the audience on this? Do we need global regulation, planetary boundary on sulfur? Or are these trends encouraging enough that the public is going to go away for health reasons?
Well, I have a question here, and that, or an issue which I think, since perhaps to you, Henning, and to Humor, and that is, we have a very well-functioning convention for North America and Europe. It says, which is sort of in a way governing the regulation and so on. But we have many regions around the world where we don't have these governing systems, or the governing systems are very weak. The question is, how can we strengthen them and to get them working and so we get an active air pollution abatement policy?
Very good question. I
Yeah,
think.
and that is the problem, I think.
Yep.
How about China, Japan, Korea area? Is there some kind of discussion among those countries to agree on a common policy?
I think that is a difficult discussion, if any, and but I do believe there are other bilateral discussions that can help, like the U.S. and China bilateral discussion, which has helped, I would say, to both promote actions in U.S. and also in China.
Any hope for Southern Africa?
In Southern Africa, there's just a lot of finger pointing, actually. You know, it's our industrialization in South Africa which is polluting the continent, and it's their burning of their fields which is polluting our bit of South Africa. So I blame you and you blame me, and no one does anything about it. But the issue is that the policies get changed depending on the governance of the country and the economic trade-off. So, for example, all those new power stations, when they were given permission to build them, they insisted that, of course, everything came with flue gas desulfurization, the best cutting-edge technology. But then when it got too expensive for our economy and our economy got weak relative to the rest of the world, that bit of the legislation disappeared. So all of those new power stations now will not have those latest technologies. So it really is a sub-regional economic issue, and I don't think it would be easily solved by a transboundary policy at this stage.
Okay, I think we're running up on time. But what both discussions about regulating sulfur more generally and about geoengineering are really showing us that we humans are now so large, so many, getting so powerful economically that we are part of the Earth system fully at the same level as the great forces of nature, the whole idea of the Anthropocene. And just go right back to the beginning of Henning's presentation, that when you look at the sulfur cycle today, it's very different from the sulfur cycle 100 or 200 years ago. So we are now bumping into how we manage ourselves and how we manage our relationship, not just with our local environment, but with the rest of the planet. So I want to thank the panelists very much for this very interesting discussion. I've learned a lot about the forgotten cycle on the planet, and I hope you all have learned a lot too. So thank you very much for coming along, and I hope you've enjoyed the seminar.